Okay, I'm recording now.
Let's solve LeetCode 1 to sum them.
Before we start, does anyone have question?
No, it's okay.
Also, if someone have feedbacks, we can like improve this PLD. Maybe we add stuff or change stuff. Let us know. Okay, I'm gonna start video. If you have question, you can raise your hand or write in chat, and we can like pause the video.
Most popular LeetCode question. So we're given an input array and some target, in this case 9. And we want to find the two values in this input array that sum to 9. So in this case, it's 2 and 7. Now we want to return the indices of these two values. So the index of 2 is 0, the index of 7 is 1. So we return 0 and 1. We're guaranteed that there's exactly one solution, so we don't have to worry about not finding a solution, and we don't have to worry about multiple solutions. Now, the most intuitive way to solve this problem is basically just check every combination of two values and see if they can sum up to our target. So we start at 2, we check every combination we can make that includes 2. So we scan through the remainder of the array 1, 5, 3, and check if any of those numbers added to 2 sums to our target 4. In this case, none of them do. So next we can repeat the process. Let's check every combination including 1 that sums up to target 4. So we scan through every element that comes after it, 5 and 3, and we find that 1 added with 3 sums up to our target 4. Notice that we didn't have to check the values that came before 1 because we already checked the combination 2 and 1 when we were up over here. Remember when we checked every combination with 2? So we didn't have to repeat that work down here. We only had to check the numbers that came after 1. So the runtime of this algorithm isn't super efficient. This is basically brute force. We're going through the entire array of length n, and we're going to do that worst case n times for each number. This means that overall worst case time complexity will be O of n squared. So can we do better? Now the thing to notice is that for each number, for example 1, the value we're looking for is the difference between the target and this value 1. So we're looking for 4 minus 1, which is equal to 3. So that means this is the only value we can add to 1 that'll equal the target. So we don't have to check every number. We just want to know if 3 exists. Now the easiest way we can do this, the most efficient, is by making a hash map of every value in our input array so we can instantly check if the value 3 exists. Now let's try the same problem, except let's use a hash map this time. Now in our hash map, we're going to be mapping each value to the index of each value. So the index of 2 is 0, the index of 1 is 1, the index of 5 is 2, the index of 3 is 3. So in our hash map, we're going to be mapping the value to the index. Now we could add every value in this array into the hash map before we start iterating through it, but there's actually an easier way to do it. If we added the entire array into the hash map initially, then we would get to the value 2 first, right? We would want to check, does the difference between target 4 minus this value 2, which is equal to 2, exists in our hash map? And we would find that 2 does exist in our hash map, but we're not allowed to reuse the same one, right? Because they're both at the same index. We can't use the same value twice, so we would have to compare the index of our current 2 with the index of the 2 that's in our hash map. There's actually an easier way to do this though, and it's a little clever, and let me show you how to do it that way. So doing it this clever way, initially we say our hash map is empty. So we get to the value 2 first of all, right? And we want to look for the difference 4 minus 2 in our hash map. Our hash map is empty, so we don't find 2. So then after we've visited this element, then we can add it to our hash map. So now that I'm done visiting it, I'm going to move to the second element 1. And before I do that, I'm going to add this value 2 to our hash map, and the index of this value is going to be 0. Now I'm at 1. I'm looking for 4 minus 1, which is 3. I see 3 isn't in our hash map, but it actually is in our array. So what's the problem? Well, for now, we're going to say we don't find a 3. So we add 1 to our hash map. The index of this 1 is 1. And now we move to the next element, 5. We check, does 4 minus 5 exist in our hash map? That's -1, so no, it does not. Then we add this 5 to our hash map and its index, which is 2. And we move to the last value in the array, 3. We check, does 4 minus 3 exist in our hash map? Now that's 1, so we see it does exist, right? Right over here. The value exists and its index is 1. So now we found our 2 values.
Okay, this part is confusing me a bit. Is anyone also confused or someone understand this one? Like, explain this technique?
Okay, I may explain here something. May I share my screen?
Okay.
Okay, share now. This window. Yes. A second. This one. Okay. You see this board? Okay. Why is it? Okay. Let's say that we will be having arrays like any numbers, like say 2, 1, 4, say 3. Okay. We need to be sure that when you are going to sum any two numbers, that you are reaching a certain target number. Let's say it is 5. Now you want to be very sure that when you are going through this array, you are moving in one direction. But here it is unsorted array. Okay, so you can't depend on moving in an ordered way. So how to get through this problem? You're just, all what you need is like a cupboard or drawer where you will save each element with its index. When you are visiting the element itself, you are saving its place. For example, I need 2. So I will say that I have a value named 2 in index 0. Okay, but I am not searching for the element itself. I am searching for the complement. So the complement is the subtraction. I need 3 for the 2 to reach 5. Here I need 3. Till now I didn't find it. So I'm just going and keeping in each step I am searching for the complement. If I find it, okay, I will return, hey, I found 3 at index say 3, but I didn't find it. As long as you didn't find the complement, just add the value and its index. So here I didn't find 3, so I'm just going on and will add, come here, 1. 1 needs 4. Did I have in this drawer 4? No, I don't have it. So just add 1 and its index. Its index is 1, right? I'm going for 4. 4 needs 1. Do you find 1? Yes, I have it in the cupboard. So I will return that I have the value 1 at index 1.
Okay,
right?
I see. So you select each number and then you go through the rest of the array.
Yes, yes.
Okay, and using 5 as like the target. So if, for example,
It's
I'm
given in the
in
problem. He is telling you that I need the target is 5. So
Yeah.
search for this array to give me that there is 2 elements with certain indices that is giving me this target.
Please, if someone have a question, maybe he doesn't understand, you can like ask. I will stream again.
Maybe.
Do you want to stream?
Yes, I will stream
Okay.
something else.
Okay.
To make it better or clearer. I think this one, yes, here. No, wait. I will share this tab, yes. Actually, this type of questions, it has two ways, but it depends. You need to ask your interviewer, is the array sorted or not? A hash table technique is much more preferable because you don't need to assure if the array is sorted or not. And this is very awesome. Also, it has a time complexity O of 1, and it is better from the another technique which we may encounter in the rest of our PLD today. So I will focus in hash table method. Here's in the example, we have this array, and I need to reach to target, which is 9. So my goal is to find the indices of two numbers here. So when I add up them, the target is 9, as we mentioned. So I will initialize the hash table as empty drawer to catch my complements. I will search for my complements, and the complement is the value which will be added to the item to get the target. Okay, so I will initialize the hash table as empty. Then here, he is iterating through the array here. As we have said, the first element is 2. 2 needs 7 to reach to the target, which is 9. So the complement will be 7. I will search the hash table for 7. For now, hash table is empty. I don't have 7 in it. So simply, I will do nothing. I will just add the element, which is 2, as a key, and the value is the index, which is 0 here, right here, 2, and the value is 0. Okay, I'm going in the same array here. I get to 7, so my complement will be 2. I need 2. Do I have 2 in the hash table in my drawer? Actually, till now, yes, I have 2. It was the first element. It is the first element in the hash table. I found it. So I will return where found. It will be 2 in the index 0 and 7 in index 1. So now I found the target. Is it clearer now, or still this is a Python implementation, taking the nums, which is the array or the list, and target. This is our drawer, which I'll keep my complements in it. It's initialized as empty. I will use enumerate in Python because it will give me the index, so I can keep in my drawer the element and its index in case I didn't find my complement. So each time, each iteration, I am calculating the complement by subtracting just target plus the number itself in the element. If this complement in the drawer, so I'm happy, I will return this complement at its index. If not, I simply will put the element itself and its index. I hope it's more clear now. And as we can see, we just iterating one time. We are visiting the elements only one time. So we are talking about time complexity O of n, and this is very good. As we can see, it's better. And I'm not confined to a sorted or not sorted list. It's okay to use this this way or this technique, whatever it is, sorted or not. Is it clear now, or any questions?
Can I ask a question, please?
Yes,
Yeah.
please.
Okay, what about if the 7 was not in the second in the index 1? If the 7 was in the last index,
Okay.
how do you analyze that?
Okay, you will keep going. This is
No,
our
just
list. I will
use the
assume.
diagram. Yeah.
Okay,
Exactly.
I will assume that we don't have 7 here,
Yes.
right?
Yes.
So I will keep going. I will visit the 11 and the 15, right? I will keep 11 and its index, 15 and its index, till I meet the 7. And this is why we are saying that you don't need to be sorted. Can you imagine it?
Okay,
Let's
so
say,
that means that for every time you encounter this, you have to add it to the hash table.
yes,
Is
yes,
that it?
yes,
So let's say
yes,
you have like 1,000 1,000 elements. You have to add it to the last before you
yes.
get there. Okay.
Even though you are talking about time complexity O of n, yes, n is associated with this 1000 elements, but at least we say that we visited each element once, only once. We will return back to this example to contrast this method with two pointers technique, which is already very good, but it needs a sorted list to work very well, and it would be also n log n. We will come here again to contrast both methods together. Nice questions, by the way.
Someone
Thank you.
asked, how
Yeah, thanks
would
so
you
much. I
have done
understand
it
now.
Great.
if it
great.
were sorted?
Yeah, I have a question, please.
Yes, please, go ahead.
What if we have another element in the array that can be summed up aside, let's say another element aside from 7, or for example, we have another 7 in the array. So how are we going to do that?
Let me rephrase the question. You mean if we have duplicates, for example, let me share here, share this tab instead. For example, here, let's say, let me, okay, 1 second, here, this. Let's say we have 3, 2, 2, 1, and the target, say it is 8. I think, I don't know. This is a nice question because in the handbook in which we are
And don't forget
doing
to hit
our
the like
plan,
button. It supports the
he
channel.
says that affirm with the interviewer if you have edge cases like duplicates. But if I am going to think with the same technique, it depends on going forward, right? Till I first, for the first time, meet the sum which get me to the 8. Let's try what you are saying. I have this hash map 3 index 0. I need 5. Still didn't find it. Add 2. I need 6. It isn't in the drawer, so I will write 2. Here is 1. Okay. Let's say 2 will also need 6. I didn't find it, so I have another 2 in index 2. At 1, I need 7. I didn't find it, so I will write y1 here 0, 1, 2, 3, right? 3, I think. At 5, I need 3, which say, yes, I have 3 here in the drawer, so I will return this element at index is 0. I think, but you were saying that what if I have duplicates? Here we have duplicates, but it didn't crash the technique. But if it will make something like I have to take in consideration something like this, I would say that it would return the first complement it will find, as if I am asking about the correct complement and found in the drawer, I'll find it.
Okay, thank you.
You got me another question, by the way. What about if we have two elements, no, say, yeah, like 2 elements, right? Consider this 4. You got me this question, and I will think about it with
Yo,
you.
Shaza, can you slow down, please? My brain
Okay,
is very slow.
Okay.
I'm trying to catch up to you. You are fast.
I'm so sorry. I'm so sorry. Okay, I can repeat as you.
Okay, just
as you
last
know me.
part.
I'm sorry. Okay. Here we are at a case, and think with me about it. I don't know while I'm asking now. 2 plus 2 are 4, right? So this sum will get me to the 4, and also 3 plus 1 also 4. If I'm going with this technique from left to right, I think it would be 3. Okay, let me.
But maybe we return the first one. Like maybe it doesn't matter. Oh, because in the two sum they say only one solution exists, so that can solve it, right?
Yeah.
If you go to the lit code two sum, I post the link.
Yeah, please.
They said you might assume that each input will have exactly one solution, and you might not choose the same element twice. Maybe that's kind of bypass this problem.
Yes, exactly. I think this makes sense. Okay. What else? Is it okay now, or we can proceed?
Let's solve leak code 1 to sum
Any
them.
question, or you want me to repeat? What?
Someone said, how would you have done it if it were sorted?
If
I
it's
think in
sorted,
that case, we don't need the hash table.
yeah, it would be. I will share this. It would be another technique which we are going to deal even in this to some problem. It's called the two-pointer technique. Here, if it is sorted, let me. Okay. Here we can use something like 2 pointers. I wanna remember it. 2 pointers.
So I guess you're gonna start from the one pointer in the left, one pointer from the right, and you're gonna move one pointer to the other.
Yes, I think this is the sliding window, Yusuf, I think, or which one? Okay, yeah, yes.
Okay, we're still looking at the blog page.
Okay, I think it is here. Share this tab instead. Okay, 2 pointers. This will be applied also in the to sum. Let me array and target. It is the same question, right? And it returns the same target sum. Yes, it is the same. Okay, let's explore this technique also. I'll get it from the beginning. 2 pointers. Okay. It's also another common technique. Okay. My voice is clear and
Yeah.
it's okay. Okay. It's very simple. Okay, and it's better than O n squared. It may be O of n, or as we have said, all n log n. It depends in a sorted array. We can find also a pair of elements that meet certain criteria, like a target or something. I want 2 elements, so I am using 2 pointers. I will be using them in opposite ends, like as we may see an array. So I will make a pointer at the left, pointer at the almost at the right, or any other place that can simplify or be implementing certain condition. Here in that case, we will, as if we are having this list, okay, and I need to get the sum to reach a certain target like 8. So I will initialize a pointer at the left, which is 2, and at the right, which should be 18. I will iterate in this list as long as the left pointer didn't meet the right one. So I will keep iteration as follows. Here, 2 plus 18 is 20. This is much more than 8. So what I'm going to do is to trying to decreasing the amount of the current sum. So I will be moving the right pointer to the left. And why is that? This array is sorted. So I am sure when I am moving this right pointer one step behind, so I am decreasing the current sum. 2 plus 11 is 13. Yes, it is still not reaching the 8, but I am less than the previous sum, which was 20. Now we have 2 plus 11. It is now 13, right? So I will need to make it again less. So I am coming here. 8 plus 2 is 10. 10 is still more than 8. So I need to move backward again to make it less. So 2 plus 5 are 7. Now 7 is less than 8, right? So at this point, I need to move the left pointer one step ahead, because I know that if I am going to move the left pointer one step forward, I am increasing the current sum. Okay, I'll repeat it again, but consider this with me. Now the left pointer comes to 3. The right pointer was pointing to 5. Now 5 plus 3 equals 8. Maybe it isn't clear, so let's go for the whiteboarding.
I think it's clear. Is anyone
It's
have a
clear.
question?
It's
Yes,
clear.
please. Clear? Okay. But this is called a two-pointer technique. It's more simple than the hash map, but as we have said, we need it to be sorted. 2, 3, 4,
What
5,
if
it's ascending.
we have like before checking the addition or the sum of the numbers, we have to check if the number is less or greater than the targeted one before starting the
Before starting what? We already do this. I have to check if the current sum is more than or less than the target to
No,
know.
it's not the current sum. No,
Huh.
before checking the current sum, we have to check the number. Like 18 is greater than 8. 11 is greater than 8. 8 is greater is equal 8. So we're gonna start loop, the other loop that go through
Okay.
the list after after we have like limited our choices between the first number that is 2 and the number that is less or equal to it.
Okay.
What do you think?
I think, let me rephrase this. You mean that I will put the right pointer. I'll check first that if the number is greater than the target, I think you mean
Please,
that.
can you just whiteboard for us? The way
Okay.
you are doing this is very confusing.
Okay. Let's delete this. I think I got you, and I think this is a smart way of solution, but I don't know if it's applicable. We have to say something. A second. If we have, say, 1, 3, 6, 7, 8 to keep it sorted. Okay. And let's say the target is
I can't
like
see your
14.
screen.
Okay, I'm share this tab instead. Okay. I forgot about it. Okay, this is the target, right? Okay, I think you mean that I will check first if the 10 is less than 13. So I don't know. You want from the first to detect where the right and left pointers from the beginning.
Yeah.
I think this is smart, but how to apply it? I don't know actually. This is smart, yes, I agree, but
You
how?
can apply it before before checking the sum, because if the sum is an operation. If the sum takes a time. I don't know how much time it takes, and also the comparison between this sum and the targeted number takes another time. So if we just like checking the number before doing the sum, we like increase the time of this operation. That makes it like faster than
I agree with
I don't
you till a point. The sum itself as an operation, it isn't the time-consuming step. It's operation. You are just.
So it doesn't take
it
any
isn't.
time?
No, but visiting. I think the thing that takes time is how frequent you are
Yeah.
visiting each element.
Yeah,
As far as I know.
yeah.
Okay.
Yeah. But yeah, also time takes an operation takes like I don't know how much, 1
I think this is a
milliseconds or
fixed
something like.
time. I think this is
Yeah.
a fixed time. In terms of what? Of time complexity or notation.
Yeah. Oh,
Okay.
yeah. It's a fixed
So
time. Yeah.
I think some or any math operation is fixed time complexity. The issue of how frequent I need to visit them. I don't know how to apply your point, but I think I will search it. I will search GPT about this, because the question that I will use how to set my right and left pointers in a more smart way, so that it isn't. I don't have to make this left and the last one is right. Okay. How to make it smarter to be from the beginning more concise for the positioning of left and right pointers. I agree with this, but I need to search this. I don't know actually.
Okay. I'm gonna do my search also.
Please share it with us in the maybe resources or the channel. Most of which can we discuss solutions where in which channel?
So I create a forum and I create a post for array to some.
Okay.
So if you go to Discord in the forum topics, you're gonna find it there. We can discuss each topic there.
Okay.
Thank you. Okay.
Okay. Great. What else? Now, up till now, we discussed the two techniques, which are two pointers and hash map techniques, right? I think we can complete or continue in the video.
Okay. Does anyone have question? By the way, if you feel like you're confused or you're not catching up, it's normal.
These techniques are very hard at the beginning to grasp, but the positive thing is I found out that if you grasp one technique, you may find it suitable for many problems to solve with it.
Okay, I'm gonna play the video.
Okay, I will stop sharing. Okay, go ahead.
You can see my screen.
Yes, okay.
Yes.
Okay, continue.
Values that sum to the target. And we want to return their indices, which are going to be 1 and 3. So with this algorithm, we don't have to initialize our hash map. It can be initially empty, and then we can just iterate through this array in one pass. Now, the reason the algorithm can work in that way with just one pass is this. So let's say we had a giant array, right? We know for sure that there are 2 elements in this array that sum to our target, right? We don't know where they are. They're at some arbitrary location. When we visit the first one of those elements, our hash map is only going to be this portion of the array. It's only going to have the values that came before the first value. So we're going to notice that the second value that can sum to the target is not going to be in our hash map yet. But once we get to the second value, our hash map is going to be this portion. So every value that comes before this, right? So we're going to be guaranteed that once we visit the second element that sums up to the target, we're going to be guaranteed that the first one is already in our hash map, so we're guaranteed to find the solution. Now, since we only have to iterate through the array once...
Can I return this part, please?
So every value that comes before this, right? So we're going to be guaranteed that once we visit the second element that sums up to the target, we're going to be guaranteed that the first one is already in our hash map, so we're guaranteed to find the solution. Now, since we only have to iterate through the array once, and we're adding each value to our hash map, which is a constant time operation, and we're checking if a value exists in our hash map, which is also a constant time operation, the time complexity is going to be big O of n. We are using extra memory, right? That hash map isn't free, so the memory complexity is also going to be O of n because we could potentially add every value to the hash map. So now let's code the solution. So remember, we need a hash map, right?
Before we jump to code, is anyone have question, or I can like go back to some parts if you yeah, Kanu, go ahead.
I want to understand. So if you get the hash map, then there's a particular like element of the array seen in the hash map. If you go on to find the second element that adds up, well, how do you like remember the former one? That I don't like articulated that properly.
Okay, can you repeat the question because I didn't hear it well?
Okay, I'm saying that say you get the first element of you keep on adding elements to the hash map from the array, then you finally get this second element that adds up to the particular target. So how do you like know how do you like get how to explain this? Let me get the question better and get back to you.
How do you get the index of it?
Yes, exactly.
Someone wanna answer this question? It's like saying, I think,
Hello,
when
can I
you
take a
are,
shot at this?
yeah.
Yeah, so at least the way I understand how to solve this problem using the hash map, because there are multiple ways to solve the problem, is that the keys in your hash map are actually the complements, right? And their values are the index of the number that is a complement of the complement, right? So when you look through your lists, for example, if you have, can we see like an example list, right? Say, for example, I think the first example is, I think the target is 9 and your areas, I think 2, 7, whatever, right? So when you get 2, the complement for 2 is your target, which is 9, in this example, minus 2, right? And that's 7, right? So you check if your complement is in your dictionary. That means you're checking the keys, right? And if it is not, yeah, 2, 7, 11, and 5, and your target is 9, yeah, exactly. So when you look through these norms, the first value you check is 2, right? And you get a complement by subtracting 2 from 9. So you say target minus your norm. If you use Python for norm in norms, you get 7, right? You then check if your 7 is in your hash table because you are storing the complements as the keys, right? So, right? So when you check 2, you get a complement of 7. At that point, your hash table is empty. And you check if 7 is in your hash table. It is false. Then you have to add hash table, right? You add the complements and the index, right, of the value. Does that make sense?
So you say add the complement and the
No,
index.
yeah, it's a key value pair. There are different ways to go about it, but some people like to add the complements, right, and the index, right? Does that make sense?
Okay.
Some people like to add the actual number, right? So yeah, it'll be 2 that are going to your hash table and the index of 2, right? Or you can have your complements, right, and the index of 2. So the example I like to use the complement as the key. So when you now get to your next value, which is 7, you say is 7. You said 7 is your complement, right? This is your number right now. You want to check for the complement, right?
Yeah.
In this example, you're actually checking for the actual number. So you now calculate the complements. You say 9 minus 7, and it gives you 2. You now check is 2 in the hash table, and the answer is yes, right?
Yes.
Because you've added 2 and 0 as the index
Before
in this example.
Yeah.
So you enter the complement, it tells you check the complement is 2, and you check is 2 there. So you can now return the index of 2 by looking up in the hash table, that's hash table at complements, and return I, which is the index of the current iteration. Does that make sense?
Oh, it makes sense now. Thank you very much.
Yeah, so another way to do it is you actually have the complements as the keys, right? Like I said, it's programming. There are many ways to go about problems, but that's just how to do it, right?
Yeah, thank you very much. You answered one first.
Yeah, thank you for taking the mic. So, by the way, we're gonna see the solution, right? And because the time we have like 10 minutes for this PLD more, what we're gonna do is we're gonna jump. Like this is optional if someone wants. We're gonna jump to Discord and like create like 5-member group or 10-member, and everyone discuss with each other and like share screen, talk about it if someone have question and stuff like that. Okay, I'm gonna continue with it.
Right, I'm going to call this previous map because it's basically every element that comes before the current element. Every previous element is going to be stored in this map. We're going to be mapping the value to the index of that value. So now let's iterate through every value in this array. We need the index as well as the actual number. So let's do it like this in Python. Before we add this to our map, let's check if the difference, which is equal to target minus n. Now let's check if this difference is already in the hash map. If it is, then we can return the solution, which is going to be a pair of the indices. So I can get the first index like this, and the second index is just I. Now if we don't find the solution, then we have to update our hash map. So for this value n, I'm going to say the index is I, and then we're going to continue. Since we're guaranteed that a solution exists, we don't have to return anything out here, right? But I'll just put a return for no reason. Now let's see if it works. And it works perfectly. So with this kind of neat little trick with just doing it in one pass, you can reduce the amount of code you have to write and not...
Okay, that was a nice solution. It's kind of the same as the one Sheza show. So let's go now. If someone have question, but this meeting gonna like end up soon. So let's go to Discord. Let me show you how it work. 1 second. Okay, share screen. Stop share screen. Window and Discord. Share. Okay, everyone see my screen. So you can join this room or join create here or join people in this room needs like same and try to talk with them, share your screen, ask question, know each other. So yeah, let's do it. Let's go. Shaza, if you want to say something, feel free.
Okay, I think we can continue in Discord. This is a good choice.
Okay.